All right, so we're going to work this as a fraction. I'm going to erase. Is that cool? Oh. And all right, so once I have this, so when you talk about it's still where are we starting with? We're starting with 1, right? N minus 1. So our A n equals, and what's our initial? Our 64. I'm gonna start here and then I'll simplify. Yeah, I'm getting there. I'm getting there. No, on the function, so it doesn't ask for the function until C. So in C, we'll write the. Yeah. Did we not? It was in C, right? So here we're at A of n, and then we have 1/2 n minus 1. And I wrote minus 1 because where did I get 64 from? Term 1, the first term.
Okay, so I write this n, so 108 times 1/2 up to the n. Yeah, that's the zero. Okay.
Okay, but do you understand why I wrote it n minus 1?
Yes.
Because I did not start at 0. Agreed?
It's the first term.
My first term, I started with 64, right?
Wouldn't it be if it was the zero term, we would write just n. What's the difference? So it's the initial, the term that you're gonna put, so the number is 64, the number would be 128. Yeah. So, but like, does it actually matter if you wrote A of 1 or A of 0? Or A of 0? A of n is like, that's like.
It's like n is like, what is your, where are you starting at?
If you plug in 1 to that, you're gonna get 64. So like, does it actually matter if you use 64 if you use 0? Like, why does it really matter?
No, because 0 is one.
What do you?
It doesn't matter what term you use as long as the equation is still correct.
Yes, that's what you're asking.
As long as
Yeah.
you can plug in a number and still get the.
Your work supports what you're doing. Does that make sense? So this supports what we're doing because I said I'm just going to start with, remember I drew the arrow. I'm starting at the first term. So I'm going to use the value, the range of the, well, the output of the first term, which is 64. I noted that by doing n minus 1. But when I write my function, I'm going to take the fact that it actually starts where?
But,
0. So my f of, so here, now we're going to write it in terms of a function. So when I'm looking at f of 0 would be 128. So when I write this as a function, f of n equals what?
it would be 1 times 1/2 to the n.
There we go. Yes? We're okay? Who said no?
Yes, I think we should just do that.
See, I was always taught you use what you're given when you're predicting the sequence. That's why I use wherever I'm at. That's why that's my 1, and that's where I start. For the function, I know you're supposed to simplify and go back to 0 because functions have origins and beginnings. So I have to untrain my brain for something it's been doing for 20 years. I don't know how to do that.
I think that's all I'm supposed to do besides like when you're writing the actual function.
Yes.
Right, like that. When you're just writing the like rule.
You're just using what's given to you. And so all I see is here at 1, I start at 64. And I go from there. When it's asking,
But it says the function.
the function,
But it says like the rule or what is A of n?
yeah, it's based on the question. All right, so making sure we understand what just took place really quick. Number 9, fill in the table and just state the domain and range for me. Fractions are your friends, leave it as fraction. All right. What was the rule here? We divided by 2, which means we did what? Multiplied by 1/2, right? So what was next? 72, then we had, and then 9/4. 9/2, no, as long as, at this point for like basic math, they don't expect to see necessarily that.
And for number 10, like when you're writing at the end, you have to show like writing A and then birthday days.
I wouldn't make you personally. All right, so here clearly our domain for what we can see, remember, it's just based off what you have in that table, right? So the domain of this table is just 1, 2, 3, 4, 5, 6, 7. Agreed? The range of this table, because they want to make sure, I don't know. I says part of our objective is to be able to state the domain range of geometric and arithmetic sequences from a table and a graph. This is set notation because we're using the braces. So we have 144, 72, ... Yes, agreed? We're all comfortable with that. I am, my notes. It's not like writing the rest of it.
Oh, but it stops at 9.
Yes, it stops at 9/4. ... up into 9/4. Okay. All right. Now it's specifically said for the function, right? So the function is going to be our simplified format, correct? What is our simplified format here? F of n equals, oh, ignore that. What is our 0? 288. So our initial times our change. What is our change? 1/2 to the n. Yes. There's parentheses, brackets, and braces. It's bracket, parentheses, brackets, and braces. Thanks. My pen is on its own mind.
Wait,
So they're all forms of grouping. Typically, brackets and parentheses are interchangeable. Braces are usually when you're listing out information, mathematical information. Good question.
wait, for number 10, like like what word do you use to know here early there?
Because it said to find the exponential function. So a function is a model that helps you demonstrate a table or graph, right? So if I just wanted any value from here on out, what would be the model I could use to make that possible? Yes? All right, ready? Okay, so now it says we're going to be looking at geometric sequences in the explicit format. Just summarize what we talked about. When you have your sequence, g of n equals your initial g sub 0. That's what this is. Or g naught if you're in physics. I don't know if they ever say. Sorry. You heard nothing. Okay. G sub, we'll keep it as g sub 0. Yes. Okay. All right. You never heard that P word in here. Okay. Your rate to the end. Okay. It is equivalent to the exponential model of f of x equals a times b to the x. Okay. Similarly, if you are not starting with g sub 0, you're starting with g of n equals whatever term you're starting with, right? And n minus that term. Okay. That is our overall appeal. So even if it's 0, it's still going to be n minus 0. So this is your overall geometric sequence rule. Got it? How is that equivalent to your exponential? Well, it's equivalent to your exponential because it's going to be y1 r to the x minus x1. That's its equivalent form as a function. Okay, r is still your ratio. How are you changing? Your ratio is what are you multiplying by, right? Yes. And yeah, that's pretty much it. Doable so far? And no, this cannot be all we learn. Okay. All right. So now looking at this guy here, this time we're looking at the increase, right? We've been looking at decreases. Now we're looking at an increase, right? So that lets us know that our R has to be greater than 1. Otherwise, it would be a decrease, which is what we've been analyzing. And yeah, so since we're no longer decreasing, R has to be greater than 1. So what are we doing here? We have 1 is at, looks like 3, and then 2 is at 6. So we're multiplying by 6, 12, 24, 48, 96, ... Okay, so in terms of subscript notation, this is A sub 2, A sub 3, A sub 4, A sub 5, A sub 6. So then it would be A sub n. In terms of function notation, we have f of 1, f of 2, f of 3, f of 4. I don't know why I did that. F of 5, f of 6. So we're looking at f of n. Okay, so our subscript notation is starting with the given information. Does that make sense? I want to teach it a different way, but it's just in my brain. We start with our given information. So A sub n equals, where did our table start at? 3. Make sense? What is our ratio? So R equals 2. So 3 times 2, oh my gosh, to the n minus 1. And why is it minus 1? It is the first term. Yes? Okay. If my table had started at 2, then it would have been n minus 2, and I would have started at 6. Yes? You agree? Okay, cool. Function. Function, now we are simplifying. We're reducing. We need to know what is our initial value. What is 0, right? So in the case of this problem, what would our 0 be? 3 divided by 2, which is 1.5, 3 halves, correct? Yeah? So if we looked here at our A sub 0, it would equal 1/2, or it can be an exact decimal of 1.5. So when we write our function, you didn't see that.
Make sure we saw it.
Yep. So f of n equals our 0 value. What is going on? No, my pen is not good. And the crazy thing is, it does not do this and dual credit. It doesn't. It's the same pen all class.
Like,
No, I've never even charged this thing. All right. And then we are 2 to the n. So subscript, function notation. Good? Not good? Doable? All right. I've always thought your subscript is given information. Your function model is from there.
On our, like, homework, if we did A sub n equals,
As long as it matches what is supposed to be there, I'm fine.
so like, if we did, like, if we put the 1.5 times 2 in, or like, as A and then.
I'll be fine. I'll just, at this point, yes. But as long as we are able to distinguish between the two, if it was tested, right? Okay. All right. Now let's go the other way. What if I give you the function? Can you tell me vice versa?
Wait, what?
So here's your formula. You have A of n equals 6 1/2 n minus 1. What is this telling me? What is my given information from here that I know? We're decreasing. So it's a decrease. And therefore, we know that because our R equals 1/2, right? Okay, what else do we know? The first term, your A1 equals 6, correct? We can tell all of that just from reading what was given. Okay, when you're listing out sequences, you typically start at 1. You do not, there's no 0 sequence. Does that make sense? It's first, second, third, fourth, fifth. Okay, there's no 0 place. All right, yes. Why is there no zero place? Because it's talking about an order of events, and in order of events, you typically don't. Mhm. Like, if that was the case, then someone would get an award for being in zero place, and that. All right, so when we're listing out our first six, that means we're listing out A1 through A6. Yes, does that make sense? So what is our A1? That's a brace. It's a brace, and y'all was gonna pretend that it's a brace. It's a brace. It's a brace. I don't know what happened, Jude. Then we have 3. Then we have 3/2. Then we have 3/4. Then we have 3/8. Then we have 3/16. Each one is being multiplied by 1/2. So 6/2 is, not 6/2. 6/2, yeah, 6/2 is 3. 3/2 is 3/2. So we're multiplying each one by 1/2. All right, so with that, what would our A sub 0 be? If we had to make a prediction, it would be 12. If I wanted to check it out or follow the rule, I would do 6 times 1/2, and it would be 0 minus 1. Does that make sense? Plug it in, and I'm going to end up with 12. That would be you showing your work to support the work. Would be plugging in 0, 4, in.
So -1 power with the. one.
Exactly, it reciprocates. And then it becomes multiplication instead of division. Yes,
Wait, instead of a 0, you put a 1, and that's 1/2 to the 0 power. What would that create?
what?
1.
Yeah, it takes us back to 6.
So anything to the 0 power is 1.
Anything to the 0 power is 1. Yeah, sorry. No, it's simplified. It's our 0. Remember, exponential is your 0 form. So it'd be f of n equals 12. Our exponential is our function notation. Yes, I'm on the same words to you. I didn't hear that. I don't know what I heard. All right. Are we filling it? Sequence and series are our friends. We're not against them. All right. Let's make sure we can do it from a word problem. Okay. Here we go. Tim released a helium-filled balloon that rose 200 feet in the first minute. And each succeeding minute, the balloon rises only 50% as far as it rose in the previous minute. Write a general formula, A of n, that gives the number of feet risen during the nth minute of the balloon for time in the air. So we're going to establish what we have, right? So what was given to us? And that's our A of 1. So they gave us our A of 1 equals 200. Agreed? That 50% represents our what? Our R. So our R is 1/2. Okay, so when he first released the balloon, it went boom. But now the balloon is going to slowly start doing what? Decreasing. It's going to slowly, forever, take a month to come back to the ground, but it's going to eventually make its way back down.
But wouldn't it be it's rising?
Yeah, because it says only rises 50% as far, so it's still going up, it's just not as quick.
I would say
Maybe
it'd be
1/2 less than the 5.
Is it going up?
Yes.
when it rises only 50% as far.
Guys, y'all really need to be with me when I'm writing this, because that's not how my brain took this.
It keeps rising.
So would it be like 1/2?
Half of it would be decreasing, it would go down.
I feel like it's losing helium, so doesn't it?
It might be like. Like it's like this. It's gotta be like this. We only have this portion of.
Yeah, like the balloon is rising, but it's going only a certain amount of, it's not going as high as it did initially.
But it's still going up.
So these are the values that has gone up from 200. So it's like it's at 200 and then it rose 200 feet and then it's going to rise 100 feet, so now it's at 300, then it's gonna rise.
I thought our Y value was the height that it was at.
No,
Height that it would be at that point.
yeah, no, the total height that it will be adding up all of those together to find where is it at.
It's just the feet it rose in.
Yes, it's just the feet that it rolled in a minute.
Right, that way, and you're saying that now my Y values are the height it's at that moment.
So we're gonna multiply by 1.5 instead of a half.
Could you do it, like, I understand what you're saying, like, and you didn't really, like, could you do it the other way?
Do the math, I don't know.
Because
I didn't think
then
that-
when it gets to
my brain didn't go that
question,
far.
it asks you how high is it at 8 minutes, then you already have it on your table, how high it is at 8 minutes.
I see your logic.
Like, 'cause I did it all, like, already, and it worked.
What did you get as your total?
3,417 point something.
I got 398.
198.
Yeah, I got 398 as my total height of my balloon after 8 minutes. Because it's rising, right? So it still has enough helium where it's still rising, it's still rising. It's just not rising as fast as that initial takeoff.
Yeah.
Cause it's decelerating.
Yeah, you're slowly losing helium, but also rising at the same time.
Yeah,
That's what she's saying, but I did it as 0.5. And then I added up in total how high it was.
It goes.
No, these are healthy math conversations, guys. I love our conversation. Yeah.
Why it doesn't work for like why? Like why is it different?
Because I think with 1.5,
Oh, so it's decreasing.
it's decreasing at the rate it's rising.
Wait, hold on.
It's decelerating as it rises.
Only
Yes.
50% as far.
It's like 1.5. It's decreasing as it goes up.
So this is what I thought. So this, you let go of your balloon, right? And it quickly rose all the way up to 200. Now, a minute later, it's now only going to rise up to 100. It's at 300, but it's rising.
Yeah, it's not
The B says define the height of the balloon.
Like
If you put 50, you're saying it's at 50. That's not.
It says after 8 minutes, which is why I totaled after 8 minutes.
You said so after 8 minutes you add.
I added up all those numbers.
You got what?
398.
The height after that minute.
I don't know why are you. I got 398.4375.
So for your
I put 100. So at this point, it's now 300 feet in the air. My third value, I got 50. And now it's,
75.
But that's going down.
yeah, because it's still up, but it's just risen.
It's 25.
So now it rose 50 feet. Now it rose 25 feet. Now it rose 12.5. Now it rose.
I understand what you're saying.
Did I do that wrong? Is that my wrong logic?
That's saying that at 3 minutes, your balloon is at 50 feet. So that's saying the height.
I'm not saying it's at 50 feet. I'm saying this is saying that it's
Feet that it rose.
at
You
the-
said part A define the height of the balloon. What would that be saying? After 3 minutes. But like.
That
Then
minute
at
it
8.
rose.
No, like, that's saying.
oh man. Okay, so again, my logic was this is it, but this is telling me how many additional feet I've risen above.
Yeah, the 1.5 doesn't work, like, because it's taking the number before it and multiplying it.
Yeah.
just half, like, I don't know how to put it, it just doesn't work.
Yeah, because you're just building on, it's like earning interest. So the 1.5 says I'm speeding up and I'm,
But it's plus half of the original value. it's not
Yes.
Plus half the value before it. That's
Yes.
what
which is why in my mind, does that not make sense? Do y'all see my little picture of this balloon rising?
I get what you're saying, I was thinking it would also work with 1.5, but it doesn't also.
So the question is saying after 8 minutes, it reaches, where is it at? So how much have I grown over those 8 minutes?
Yeah, but like, why does it say that Y is how much it rises, not where it's at?
Yeah.
It says to find the height.
Yeah, cause it says find the height after, so how would you know you're supposed to be like three?
Because on the homework, there was one that was like, how many boxes of candy, and it was just the 7th one. It wasn't like.
The total boxes? Did you ask for the total box?
Yeah, it's just total
It asked for the total. So you would add them all together.
Oh, I need to look at that. I gotta redo that.
So it's like this one in Essential, because you're asking for after 8 minutes, what is the height of the balloon? Where is the balloon at this point?
Wait, 875.
Hopefully I didn't have it wrong. I got 398. So I did 50, then I had 25, then I had 25 half. Well, you keep going from there.
Every time you're taking. So you get 25, then you get 12.5, and 6.25, and 3.125, then.
Yeah.
0.562.
That's what I have.
Yeah.
I have 1.5625. And then I added all those up.
So then I did it as the actual value. Look, I got 200, then I got 300, 350, 375, 395.
You got 398 also? Oh,
Yeah.
see, I got 3. Yeah, I think you may have missed a decimal. Did you get 398.4375? Okay.
Yeah.
All right, so in my mind, there should be a third thing here, which would be the height. Does that make sense? So this would be the column. There should be a box that says the height of the balloon.
And that's where we're putting all these items.
And that's where the total values are coming in at.
Yeah, ours says high, you're supposed to be.
So I check.
Oh, yeah.
See, that's where it's confusing. The feet is how far it's gone, but its height is not its feet. So the height of the balloon here is 200. Oh my gosh. But the height of the balloon here is 300. The height of the balloon here is 350. The height of the balloon here is 375. The height of the balloon here is 387.
It like does 1.5 times the one before it instead of times the initial. This is like 1.5 times the initial.
This is let's try that again. 87.5. If my pen stops being a little turd, I would greatly appreciate it. I don't think that's how it works.
393.75.
Got 398.
398.4375. But do you get what I'm saying?
Yeah.
So like these are the amount it should say feet on your table instead of height, because the height comes from adding up where it's at. Yeah, I just didn't keep writing.
Wait, what are the next ones? I think this is our high stuff. What are the next values? Whoa. What was that?
Graphing parabolas and quadratic inequalities.
It's like a point length.
No, it's graphing the inequality of a quadratic in a linear function.
Oh, that's great.
Yeah. So I'm at 387.5, right? And I add 6.25. I'm now at 393.75.
Add 3.125.
So I'm at 393.75. Stop doing that. And then I add 3 and 125 thousandths. And that puts me at 396. And then I'm going to add the 1 and 5,625 thousandths. And that puts me at my 398.
Oh, I know what I didn't know. Okay.
So I have 396.875. And then I'm at 398.4375. And so that's the height of the balloon. So does that help changing it to the feet it's grown and then having that third column?
Yeah, that way. I just feel like I wouldn't have known the problem. I couldn't do it.
Yeah. And I really wish I knew how to tell you how I knew to start with the 0.5.
In my mind, I was just thinking 0.5, but obviously when I did it, it didn't work. So like, that just like made sense.
Yeah. I think I noticed it here and I changed feet on mine, but didn't realize that it wasn't changed on y'all's. So the total after 8 minutes, the balloon is 398.437 feet. All right. I love these conversations, guys. That's why I don't edit our videos. People just can see the struggle of us all together. Who knows? They're raw and unedited. All right, here we go. Let's hope I didn't ruin the interpretation of this word problem. Here we go. Big Tech Electronics advertises a monthly payment plan for the purchase of the best-selling tablet. Buyers pay $50 at the end of the first month, $55 at the end of the second month, $60.50 at the end of the third month, and so on and so forth, like for 1 year, right? Let's try to write this out. So we agree that it's an A1, A2, A3. We're all there. I'm not crazy there. All right. So we know that A1 equals 50, A2 equals 55, and A3 equals 60.50. Yes?
Yes.
Okay, we're going to find our R. In order to find our R, if we're looking for what we multiply, we're going to have to do what? We divide. Exactly. So we're going to find our R. R is going to equal our second term, which is 55 divided by our first. So we have 55 divided by 50, and we get what? 1.1. So we all agree that our R is 1.1. Yes, because it's an exact decimal. It's not a repeating decimal. It's 1 1/10, right? If it was a repeating, I think they want you to leave it as the fraction. But because it's an exact decimal, 1 1/10, we are good. All right. From there, can I create my rule? Yes, but we're not asking for the rule. That's for what's your 4th, 5th, and 10th term. What's my 4th? And how did you get that? Exactly. So to find A4, we would do 60 and 50 cents times 1 1/10, and we get, it would be $66.55. So this company is saying, look, we're helping you. Every month, we're giving you an opportunity to increase your payment to pay off your item. I don't know if I like that plan. I think I would like equal payments, but whatever. Big Tech Electronics.
So it's like you're just paying like a percent more each month.
Yes, until you pay off your payment of your thing. So now we're on month 6. What would be month 6? You got 53? I got 53. Did you get 53? 80.53? Yeah, I'm listening. I'm not subtracting. It's ratios, geometric, so it's division. We're multiplying.
Yeah, but like in the exponent, isn't the in minus
You
whatever?
didn't make a rule.
We're not, we haven't made the rule yet. We're trying to see if we can do it without.
I made a rule.
Yeah. I mean, you would have to for 10 at this point. All right, what about A10 on the 10th month? He's almost paid it off. Now he's paying $117.90 from month 10. Okay, so it wants to know what would be the total payment for his plan.
And 12.
So we need to find A of 12, but then we have to do what with all those values? Add them up, because he's made every single monthly payment.
Oh,
Does that make sense?
that makes sense.
Yes? Okay, so the finest total, that means we need to know from A1 all the way to A12 and find the total of that. Yes?
Yeah.
Okay, all right, so we're going to create our rule and cheat to do it in the calculator. So that's what I did.
Like use the table.
I used a table in the calculator.
That's what I was gonna do.
I was like, I use a table in the calculator. I'm not gonna lie to y'all. So our rule, what's our rule? Where do we start? Start at 50. And then what's our rate? 1.1. And that's gonna be
Wait, is that
n minus 1. Huh?
Is it in?
It's a questionable n, yes.
Oh, okay.
You can't write AR people.
Really? Ignore him. All right, so we're gonna go to the calculator. And I'm gonna let the calculator find the values for me. I'm gonna show you a different way so that I can still use n, but yeah. I think it's gonna work.
Are we needing to write down the value?
There's a way to turn it on. You know what? It's just gonna become X. I thought I could figure out how to turn it on. You know how it has like the N right there? I know there's an N. I feel like we could use it somehow,
Weirdly expensive file.
but I don't think we can. Oh, I'm right. Stat. Edit. Duh. I was right. I thought I was going crazy. All right. So now I'm actually not going to Y1. I'm going to my list. So in my list, I'm going to put in my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are there's 12 months in a year. We agree?
Yeah.
Even if you don't, then there's 12 months in a year. So what we wanted to do is to apply our ends, which are our numbers listed in list 1, to the column, the value in L2. Yes? So we're going to type that in here. So you're going to tell it to do that. So I want 50 parentheses 1.1, and I'm good. But instead of N, we want L1. To get L1, we have to press second 1, and it will put the L minus 1 for us. We have to do second 1, and it's going to hit enter, and it will populate every month value for us. Yes. Do y'all need me to do it again?
Yeah.
All right. So I'm going to go back to L2. So in L2, notice how it's bold over L2. Yes. I'm going to type out what we said our rule was. Our rule is 50 parentheses 1.1 to the N minus 1. However, my N values are listed where? In L1 column. So I'm going to press second 1 so that I can get L1 there. Hit minus 1. Hit enter, and it's going to populate every monthly bill that I have to pay. Does that make sense? So now I have all of this. Went, okay, that's how much I got to pay. Cool, 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 cool. Now I want to know what is the total of that without me having to type in every single one of them. Okay, there is a way to doing that. You're going to hit exit. And we wanted to find the total, our sum for us. We're going to go to stat. And we're going to go over to where it says 10. I lied. Don't do that. Go back home, but don't press that. We're going to press second stat. And we're going to go to where it says math. And you see where it says sum? Do we see sum? All right. I'm going to press 5 for sum. And I want it to sum everything in L2. To do that, I press second 2 and hit enter. And it's going to tell me the total cost of my tablet. Okay. You press second 1 or second 2 is where your L1s and L2s are. All right. Oh.
It's mine, I swear. I know. Mine was so weird.
All of your values.
Oh, how much?
Yeah. It literally got stolen in 2010.
You gotta be as long as I can like that's good for like
I don't think you could.
All right, how do we feel about the last part is generating and using a calculator? Are we okay? Who needs me? I'm coming here.
I got a big screwdriver. Is that? I don't think I can do it. Okay, a billion for someone to do it to me.
Anybody else? How do we feel about allowing the calculator to write our values out for us?
I'd say five.
Doable, terrible? Does anyone need me to go back over it?
What do we put for like,
Yes, well, what do you mean? When you're putting in the calculator? Let me come to you.
Let's go over.
I called one. You need a calculator means?
Yeah. What is Right.
Stop sneezing.
This is the total from.
I don't know what to get at.
I was about to go write it.
Bless you.
All right, so we got the sum. How do we feel about the calculator? Do we need me to go through it again? Anyone didn't do it? All right, so when we figure out our total cost, we have to add up all of our payments, right? Your total equals all of your values from A1 plus A2 ... all the way up to A12. Agreed? All right. Could you add up all 12 numbers yourself? Yes, but would you want to do that? And if you're taking a time assessment, would you want to use your time to do that? No, that's why we introduced our handy dandy calculator friend here, right? So in the calculator, we went to stat, went to our edit, we inputted our values that we wanted. Yes, so we inputted our values for our L1. We wanted 1 through 12. And then L2, we put our rule in. So the rule, again, when you're putting in the rule, make sure that it is bolded. So you need to be on L2, not in the box below it. And then you type your rule in. When you're putting the rule in, you're not putting in, you're putting list 1. So your in, when you're typing in, is going to become your L1. Okay, that's because that's where your in values are listed. Does that make sense? Okay, then we define our total. We went back to our home page, our calculate page. This time we had to press second stat, and we're gonna go over to math because we need to do a little bit of math with this. And we're looking for the total. Another word for total is sum. So we went down to the sum. Okay, the values for our sum are all in list 2, correct? If you put in list 1, all it's doing is adding up weirdly your months that you're on, your terms, right? So we hit second 2, hit enter, and then we got our value. So how much was this device? It probably was an iPad. Let's just be honest. And 21 cents is what they paid ultimately for their device. Does that make sense? Yeah. So our rule that we follow, our geometric sequence is A sub n equals 50, 1.1 to the n minus 1. From there, what would be our function rule though? Anyone? How would I find my 0? Divide. Instead of multiplying, I would. Exactly. And we'll leave it as that. So prime example, when do you use a fraction or a decimal? So when I do 50 divided by 1 and 1/10, it looks like that, right? That is not an exact decimal, is it? No, it's actually repeating 45, 45, 45, 45. So I'm going to do it again, but this time I'm going to make sure I ask for a fraction instead of a decimal. Oh, fudge sickles. It's all right. Easy fix. Thank you. So I'm going to go to math. You see where it says frock? I'm going to add that in there. So now it's going to tell me 500 over 11. So now when I write my function notation, it equals 500 11ths times 1.1 to the n. Second 1, second 2. So if you see it, no, on the keypad.
Second and then 1 or 2.
Yeah. Well, you're probably finding something, right?
You're trying to find some.
Oh, I don't know.
Yeah. Your problem is, we're gonna. What were you at?
I have, but it's like I.
Under staff. She was in white.
Yeah. Yeah. All right, so in terms of this, what's happening? In terms of this problem, what is happening? There you go. So usually that means you are paying a 10% interest, right? You are paying 10% interest on your balance each month. Yes. Are we good with the calculator? We sure? All right.